You see them everywhere, right? These giant, graceful symbols of a clean energy future spinning away on the horizon. But have you ever stopped to think about what happens when they get old? After about 20 or 25 years, when they reach the end of the line, well, that's when their clean story starts to get a little complicated. And just how complicated are we talking? Well, by 2050, we're projected to have 43 million tons of waste just from the blades. That is a literal mountain of high-tech trash with almost nowhere to go. So what is it that makes these things such a massive problem? You see, about 95% of a wind turbine, we're talking the big steel tower, the gearbox, all the mechanical bits, that stuff is actually pretty easy to recycle. But the blades are a completely different beast. They are built to be incredibly tough and to last for decades, which is great when they're making power, but it's a huge headache when it's time to throw them away. And that right there is green energy's big hidden problem, the challenge of what to do with all this composite waste. So let's break down exactly why these blades are so hard to handle, and then explore the two cutting-edge ideas that are battling it out to solve this thing. Okay, so the core of the issue is the material itself, glass fiber reinforced polymer, or GFRP. It's a super strong, super light composite material, and because it's so tough to break down, for years, the only real option was to just bury them in a landfill, but that's not going to fly anymore. As you can see, countries are starting to ban this practice, which is forcing the entire industry to get creative and fast. And all this pressure has really lit a fire under the industry, giving rise to two major contenders in the race to recycle these blades. So we're going to frame this whole thing like a prize fight, the veteran versus the newcomer. In one corner, we have cement co-processing. This is the veteran. It's the established, reliable method that's already out there in the world doing its thing. And in the other corner, we've got pyrolysis. This is the newcomer, a super innovative, high-tech process that promises a truly circular, sustainable future. Let's dig into how they actually work. The veteran's approach is actually kind of brilliant in its simplicity. First, you just shred the blades into little bits. Then, you feed those bits into a giant cement kiln. The plastic-like resin in the blades burns, providing energy and replacing fossil fuels, and the glass fibers and minerals that are left over, they just become part of the raw material for the cement itself. It kills two birds with one stone. Now, the newcomer, pyrolysis, is a whole lot more high-tech. It also starts by shredding the blades, but instead of burning them, it heats them up in a chamber with no oxygen. This causes the material to basically break down into its original parts. You get some oil, some gas, and, this is the important part, you get the glass fibers back. And here's the real game changer. Those fibers can be cleaned up and melted down to make brand new, high-quality fibers. We're talking true recycling. So we have two very different ways of doing things. But the big question, right, is which one is actually better for the planet? Let's take a look at the environmental scorecard, and we'll start with how things look right about now. And this is where we get our first big surprise. Looking at the projections for 2030, you'd think there'd be a clear winner, but it's a dead heat. For every ton of blade you've recycled, the cement method avoids about 875 kilos of CO2, and pyrolysis is right there with it at 858. It's basically a statistical tie. But, and this is a huge but, let's fast forward to 2050. Now look, the picture totally flips. The veteran's performance stays pretty much the same, but the newcomer, pyrolysis, suddenly pulls way, way ahead, avoiding over 1,000 kilograms of CO2 per ton. It becomes the undisputed climate champion. So what on earth is going on here? Before we solve that mystery, we've got to look at the other critical factor in any real-world decision, the money. Which one of these actually makes economic sense? And this, too, is a tale of two very different costs. Okay, so in 2030, it's not even a contest. The veteran wins by a landslide. Using the cement method costs about 305 euros per ton. Pyrolysis, because it's newer and way more complex, costs more than double that. And that right there is why cement co-processing is the main solution being used today. It works and it's affordable. But let's jump forward to 2050 again. Well, look at that. The cost of the cement method nearly doubles, mostly because of rising energy prices. Meanwhile, pyrolysis gets way more efficient and its price comes down. The gap shrinks to the point where they're almost competing on cost. Which brings us right back to our big question. We've seen that pyrolysis gets better for the climate and more competitive on cost over time. So, what's the secret sauce? What's the hidden factor that's driving this huge improvement? Well, it turns out the answer isn't really about the technology inside the recycling plant itself. No, it's about a much bigger story that's happening all around it, the greening of our entire electricity grid. Okay, remember how we said pyrolysis is powered by electricity? Well, in 2030, our grid still has a pretty big chunk of fossil fuels, like natural gas in the mix. So all that electricity pyrolysis needs comes with a hidden carbon footprint, just from the power plant. But by 2050, the grid is going to look totally different. It's going to be dominated by the very same wind and solar power these blades were designed to create. So when pyrolysis is running on almost 100% carbon-free electricity, its own carbon footprint totally collapses. Its biggest weakness becomes its greatest strength. So, after all that, after looking at the environment, the money, and the secret ingredient of the grid, what's the final verdict? Which one of these solutions should we be betting on for the future? Let's just put it all together in a final scorecard for 2050. The cement process? It's got a good climate benefit, and it's a mature technology. But it's what we call downcycling. The materials are never turned back into something of high value. Pyrolysis, on the other hand, offers a better climate benefit, its costs are falling, and, this is the big one, it offers true high-level circularity. The only check against it is that it's still an emerging technology. This quote from the research this whole explainer is based on just nails it. The most circular solutions may not always be the most environmentally optimal, yet can improve substantially under future-oriented conditions. Basically, what that means is that the best choice isn't set in stone. It can and will change as the world around it changes. And that's the real takeaway here. This isn't about picking one winner. It's about managing a smart transition. Cement co-processing is the workhorse we need right now. It's a good, affordable solution for the blades that are coming offline today. But pyrolysis, that's the thoroughbred we're getting ready for the race of the future. A superior, truly circular solution that will be ready to go just as our energy system is. And that leaves us with a final, really important question to think about. And not just for wind turbines, but for all kinds of green technology. As we scale up the good enough solutions we have today, how do we make absolutely sure we're not holding ourselves back from investing in the truly great, game-changing solutions of tomorrow?